So in this talk, I'm going to talk an introduction to concrete, talk about concrete joints, different types of concrete joints, contraction, expansion, construction, and then the main types of concrete pavement. Okay, so let's start with the basics. What is concrete? Well, it's approximately 77% aggregate, comprising coarse and fine, approximately 15% cement, and 8% water, plus any admixtures that you add in. So, concrete. If I was to lay a concrete road here, obviously these people would have to move, but if you lay the concrete in one long strip here, what would happen is that as the chemical reactions take place within the concrete, you would get shrinkage, cracking. So it's not about the water drying out, it's about the chemical reactions that take place within the concrete. And what you would normally get is you'd get cracks approximately every 5 meters transversely, and if it was wide, you get a big crack down the middle. So that is one of the problems of constructing a concrete road. So that's why we need joints. So here you can see an example. This was a heavily cemented road. It wasn't a concrete road, but very heavy cement content, and it's cracked naturally. So you can see there are transverse cracks meandering, longitudinal crack meandering, so very difficult to seal, and you don't want this. So another thing to know about concrete is that once it's hardened, we've got hard concrete, it expands and contracts. It also, if it's hot, it also sort of hogs, it bends. So it bends that way and that way. It's like a bimetallic strip. So during the daytime, the surface is hotter than the bottom. So it expands, top expands more and it curves like that. And nighttime, the bottom is actually warmer than the top. So it curls back. And here you can see some examples of temperatures. I drilled a hole in a concrete pavement, put in some thermocouples, and we actually measured the temperature at the top and the bottom and the middle of the slab. And you can see the red is the top. Yes, the red is the top of the slab, and the blue is the bottom of the slab. And you can see the temperature differential between the top and the bottom changes, and that changes the shape of the concrete slab. So it's just something to be aware of. Okay, so concrete joints. Instead of letting the concrete crack as it wants to, for this particular type of concrete road, we introduce joints. So a joint is effectively, you're controlling where the crack happens. So there are different ways of doing this, one of which is to lay the concrete, and then where it's half hardened, you do a transverse saw cut across the pavement, and then the crack will form at that weakness that you've put there. So in the middle, you can see the saw cut is down to about 1/4 of the depth of the slab, and the crack has occurred where you've introduced that weakness. So a joint is effectively, you're telling the concrete where to crack. So this is called a contraction joint, because as the concrete cures and dries out, the concrete contracts, and that's what's causing the cracking. So instead of having the random cracks that you would have if you didn't do anything, now you've got neat saw cuts at the top, and you're controlling where the crack is. So if you've got a neat saw cut, then you can seal that and stop water getting in much more easily than if you had just a random crack. Now, if you just left that as a crack, the problem is that vehicles passing over that crack, there's a sudden shift from one side of the crack to the other, and you get differential movement. And this is a big problem because if you have a material underneath that is erodible, this constant movement of traffic going over that joint will cause a void underneath that joint. And if water gets in, it can pump out the material and you get a bigger void and all sorts of issues. So on the right there, you can see the staining on the shoulder from pumping. So the subbase is being dissolved in water and is being pumped out of the road. And eventually the slab will settle into the void and you'll get stepping. So to avoid that, we use dowel bars, which are load transfer devices. So you've got the crack running across the road. We put some steel bars across that joint, and then one side is fixed to the concrete and one side is debonded. So the concrete can actually expand and contract, but you'll still get load transfer from one side to the next. So a dowel bar is approximately 25-30 millimeters in diameter. It's smooth, 350 millimeters long, and you put them at 300 mil centers across the transverse joint. So let's see some pictures. So the normal method is to put the dowel bars on a cage where you want the joint to be before you put on the concrete. So you set up every 5 meters or whatever your joint spacing is along the road. You've got your formwork to control the concrete down the sides, and you put dowel bars across where you want it to crack. So on the dowel bars, one side is fixed and one side is free to move. If they were both fixed, then the joint wouldn't be able to open and close. So that's the dowel bars. So there are two ways of making the concrete crack in that location. One is to wait till it's sort of semi-hard and do a transverse saw cut, as I say, to approximately a quarter of the slab depth. The other is to use crack inducers, which you attach the bottom one across the pavement. You sort of fix it to the floor so it can't be moved when the concrete is put on, and then you lay the concrete, and then you can put in this the top inducer. They're normally plastic. You can use metal ones, and that is the same as sort of doing a saw cut across. So the concrete will crack in that position where you want it to.
May I ask one question?
Yes.
Is it reinforced or unreinforced?
Can be either. I'll go on to explain the reinforcement later.
Unreinforced, down position for unreinforced.
I'll explain the difference.
It is already 10% reinforcement is given. Is down written.
I'll explain the difference later on. You've got unreinforced concrete, which has joints. You have jointed reinforced, which has reinforcement, but joints, but that's a bigger slab. And then you have continuously reinforced, which doesn't have joints. I'll go on to explain that later. Okay. So yes, for the joints, it's not CRCP. It's not continuously reinforced. It's either unreinforced or jointed reinforced. But I'll explain the difference of those types of pavement. Okay, so those were contraction joints. Now expansion joints. So concrete, as I've said, expands when hot and contracts when cold. So there's actually a lot of movement at every joint. That's why if you put an asphalt overlay on jointed concrete, you will get cracks in the asphalt above every joint, because the concrete is continually expanding and contracting on a daily basis at each joint you put in. Now, expansion joints allow a greater amount of movement. So, for example, at a bridge deck, you don't want the concrete to expand and destroy the bridge. So you put in an expansion joint so that the concrete's got plenty of movement there and won't affect the bridge. Or there are other times you need expansion joints. For example, in the UK, there's such a big temperature variation between winter and summer that if you laid all your concrete in the winter, when it came to summer, they would all expand, and eventually there wouldn't be enough room for the concrete to expand into, and you would get something called a blow up, which I'll show you pictures of later.
Excuse me, can I ask?
Yes.
The previous slide you have shown that the depth of the dowels is d/2, right?
Yes.
The previous d/2 is fixed, not there is no variation. But in other course in ASTO and ISC, we have seen it departs from on d/3 to d/2 like that. There is a differential. It is fixed. Is it fixed in the TRL 31? Not 31.
It's normally about half depth for the dowels. For reinforcement, it's
Just
different.
half of the depth.
Yeah.
But in our project, we are providing it on 1/3 of the depth, following the ISC 2008.
1/3 from top.
1/3 from the top.
For dowel bars or for reinforcement?
No, down.
Dowel bars.
No, this is one, and this is the relation between this 31 and ISC 2018. And in the next slide, what you have shown here, that expansion joint width you have shown here generally 25 millimeters. But I think it depends on the length of the slab. Length of the slab and as well as the temperature variation and coefficient thermal expansion of concrete. It is a calculated, it should be calculated. And depends on it. We have reduced our width of the expansion joint. That's why the riding comfort has been given more better in our project. And there is no disruption we have seen in our computer. So it is written here that 25 millimeter wide. If it is 25, it is too wide, and in the passage of time, it becomes bigger and bigger. But is it necessary? That's the question. Thank you.
That's a standard width of an expansion joint. If you need more, then you have an expansion joint more frequently. It's, as I say, for the UK, for example, you know, the difference between winter and summer, there's a big difference in temperature. If you have a country that's very, the temperature is the same throughout the year, then you may not need expansion joints, or you could have a narrower expansion joint. So an expansion joint is different to a contraction joint. A contraction joint, the concrete is cracking where it wants to, or where you've told it to crack. An expansion joint, you are putting a compressible material at the end of the concrete. So you've got straight faces either side. The material that you put in there is, for example, foam or fiberboard or something that can compress. So water, it's not going to go into it because there's something in there already. It allows the concrete to expand and contract more than a contraction joint. So you can see some pictures there. So when do you use expansion joints. The main use is at a permanent structure for a bridge or culvert, or moving to a different pavement type. So when you go from concrete pavement to an asphalt pavement, it's good to have a transition slab, which I'll show later on, which has an expansion joint. Otherwise, the concrete will expand and contract against your asphalt, and you will get a big bump in the asphalt occurring there. So if you don't have expansion joints, how do I get rid of that? Okay. So here you can see a picture of a blow up that's occurred because the concrete has expanded and it's got nowhere to go. So the concrete's done this and then gone like that. This is a very rare occurrence. It's normally sort of, on an exceptionally hot day in summer, but it can occur if there aren't enough expansion joints. So you can see the difference between a contraction joint and an expansion joint. The expansion joint is wider and allows more movement for the concrete, and is filled with a compressible material to stop detritus and water getting into the joint. For the contraction joint, it's basically where the concrete is naturally cracking, and you introduce a seal at the top to stop water and, more importantly, detritus getting into the joint. Because if you have detritus like stones that go into the joint, obviously the concrete can't expand and it will cause problems at that joint. Okay, construction joints. Here, a construction joint is when you want two slabs to be locked together. So, for example, at the end of one day's construction, or if you're tying two lanes together, so you've constructed one lane, and then you come along and construct another lane, you want the two lanes to be tied together. So you use deformed steel bars, which have the ridges on, which enhance the concrete grip onto that steel, so it's not moving. So these are different to dowel bars. These are called tie bars. So dowel bars, which were for load transfer across the transverse joint, were thicker steel, they were smooth, and they were quite short. These tie bars are thinner, about 12 millimeters diameter. They're deformed steel, so they've got the ridges on, and they're longer, normally about 1 meter long. And they're placed further apart, normally at 1 meter centers. So it's important to know the difference between tie bars and dowel bars. So tie bars fix the slabs together. They do not provide load transfer. For example, where you've got two lanes, one is constructed first, the second is constructed, and the tie bars will hold that concrete together, and the load transfer will be provided by the aggregate interlock across that joint, not by the tie bars, but it's the fact that tie bars locking the concrete together. So construction joints. So at the end of one day's work, for example, or where stoppage is required, the concrete mixing plant's got a problem, okay, we have to stop now. What you normally do is you introduce a construction joint between your normal transverse joints. So you, for example, you cast up to a certain place, you put some formwork across the road to contain the concrete. You lay the concrete up to the formwork, and then you push dowel bars into holes in the formwork. So what you're left with is at the end of the concrete, with metal bars sticking out. So the following day you come along and you take off the formwork and you lay the new concrete against the old one, and these are locked together. So this is not a transverse joint, you're just locking the two slabs together as though they were. So, as I say, it's important to know the difference between dowel bars and tie bars. So dowel bars, they're smooth, they're sort of 20 to 40 millimeters diameter, about 450 meters long, spaced at 300 millimeters. Tie bars are thinner, 12 millimeter diameter, deformed steel bars, about a meter long. So when do you use dowel bars? When do you use tie bars? So this is an overhead view of a jointed, unreinforced concrete pavement. So you can see the dowel bars are used at the transverse joints. So you want to provide load transfer as you're driving along the road from one slab to the next. And tie bars are used to lock the lanes together or at a construction joint. So the main types of concrete pavement. There are many different types of concrete pavement. The main types are jointed unreinforced. You also have jointed reinforced. You have continuously reinforced concrete pavement, CRCP. There's continuously reinforced concrete base, CRCB, which is effectively a CRCP pavement but with an asphalt surface. Having an asphalt surface provides lots of benefits. It's a trade-off. Asphalt surface is quieter than a concrete surface. If the concrete surface, the texture wears out, then you have an issue. But if it's an asphalt surface, you can just plane it off and replace it. Then there's roller compacted concrete, ultra thin reinforced concrete, UTRCP. That's more of a rehabilitation method, but I'll talk about it anyway. And then prefabricated concrete slabs. So let's go through the different types. So a very common type is jointed unreinforced concrete pavement. So that's, as I said, that's you're laying the concrete in one long strip, but you're introducing joints to control where the cracking occurs, which is approximately every 5 meters. So on the right, you can see the joints at 5 meter spacings. So you're walking on the road, you can easily identify that's a jointed unreinforced concrete pavement. The joints are at 5 meters. So this is a variation on that. For very low volume roads, some people have used no dowel bars, so there's no load transfer. But this is only for, I would say, rural roads with no heavy goods vehicles.
But would you please explain what you mean by low volume roads? How much traffic can you say low volume? It should be defined. Definition should be there. Otherwise, we can assume the person to person it will be different. It should be specified. From this range to this range of traffic should be called a low volume traffic, and that volume to this volume is medium traffic. So on axle load base, this million axle up to this million axle is low volume. It should be like that. Otherwise, it is not. It is qualitative. I think explanation.
This is like a cheap. This is like a cheap version of the jointed concrete pavement. So I cannot put a figure on it, but if you had a few HGVs a day, that's fine. But more than that, I would not recommend. So, for example, you could use this in an urban environment if it's just a residential street. This is the low-cost option of not having dowels, but I would always recommend the other one of having dowels just in case. But I'm just showing you as one option. So it's a low-cost version. You don't have dowels, and some people like to skew the joints because the theory is that instead of having two wheels going from one slab to the next at the same time, you have one than the other, so it's less of a shock to the subbase. But this is, as I say, for very low volume units. Okay, the next.
The wet campus, we have seen that most of the internal loads are made of concrete and without dowels. And it is more than 50 years old. So in that area, light
traffic, yes.
So axle load doesn't matter. I think that should be the definition of low, maybe the definition of low. There is no axle load not countable because less than 8.16 standard axle, all of the cars or jeeps are moving over there, not the trucks or buses even.
Yeah.
So like that, it can be defined.
Yeah. Okay, so this is the next type of road. It's a jointed reinforced concrete pavement. So this is a sort of halfway between your unreinforced jointed road and your CRCP. So what you have is instead of having a joint every 5 meters, you have a joint approximately every 25 meters. But the concrete in between, you put reinforcement in. So it has the benefit of not so many joints, because joints are where the problems happen. But you still have joints. So this is like a halfway house. The best type of road is CRCP. This is halfway between unreinforced and continuously reinforced. So here we hello. Can you hear me? No? Gone off? They obviously don't like what I'm saying. Does anyone know how to make the mic work?
JRCP is that a 25 meter is mixed or
A JRCP, jointed.
less than that can be done.
It can be less than that, yes.
Our guidelines is 8 to 15.
Yeah. It's interesting. I mean, in the UK, it's 25 meters, but in Australia, for example, I think it's 12 meters. So I'm not sure why it's so short in Australia and difference in UK.
Our guidelines 8 to 15 meters.
You're following Australian.
Some project we are using 12 meters, some project we are using 20 meters. Yes. That's why that's in our normal
That's not working on. Is that working? Yes. Okay. Try that one. Ah, yes. Turn that off. Right, thank you. We're back. Okay, so the next type of road is continuously reinforced concrete pavement. So imagine you were laying a concrete road here. You put reinforcement down first, the whole length. Then you lay your concrete and you have no joints. What happens is the concrete will crack at a more frequent spacing, sort of every half a metre, 2 metres, but it will be held together by the steel reinforcement. So instead of getting a wide crack every 5 metres, you will get a very narrow crack every half a metre. So detritus can't get down those cracks because they're so fine, and water can't get in as well because there's such fine cracks. So instead of getting the expansion and contraction of the concrete, instead of getting all that movement every 5 metres, you're getting a tiny little movement every half a metre. So what happens, for example, if you put asphalt on top, you won't get reflection cracking through because all that movement in the concrete is happening at a little spaces all along the road. So here you can see the reinforcement put down first, and then a paving train, and finally a picture of a CRCP. I'm sorry, it's a terrible picture of a CRCP. If you ask a road engineer to find a picture of a good road, he won't have one. All I have is pictures of bad roads and failed roads and not very good roads. So that's not a very good picture of a CRCP. But in the bottom picture, you can see the fine cracks that are occurring every sort of half a metre. So if you're standing on a concrete road, you won't see any joints every 5 metres or every 25 metres. You'll just see continuous concrete with fine cracks in it. So the cracks are meant to be there. It's not a problem. They're held together by the steel reinforcement. So one thing that you have to do with CRCP is it's effectively one long slab. So you have to contain the ends of the CRCP with ground anchors, which go down into the ground and effectively anchor that position at the end of the slab. If not, as I say, that's just one big slab, so you'll get big movements at the ends of the slabs. So here you can see a ground anchor being installed, and then the CRCP is attached to it to fix that end. Now, another variation is CRCB, continuously reinforced concrete base or road base. So it's the same pavement, but with an asphalt surfacing on it. Normally, it's just about 50 millimeters thick. But if you put thicker asphalt on, more than 100 millimeters, you could say that adds to the structure of the pavement, and then your concrete thickness can be slightly reduced. So as I said before, it has the benefits of you can just plane off the surface and replace it. And so on. Yes.
The CRCB and CRCP is the same, isn't it? There's no difference.
If the asphalt is a thin asphalt, then yes, they're the same thickness. Obviously, if you know you're going to put an asphalt surfacing on it immediately, then you don't need to do the surface texture in the concrete. You can leave it as rough, but the asphalt will adhere to it. So you don't need to spend time getting the surface texture just right.
From the picture, you can see that the cracks are in full depth. The 0.5 meter to 2 meter space cracks are full depth. Full depth crack from top to bottom,
Yes.
not partial depth. So to protect this crack, we are using the reinforcement in the top layer, right? So why not in the bottom layer to protect the crack?
What, 2 layers of reinforcement, you mean?
So reinforcement we are using in the top layer only to find the cracks tightly, right? In the top layer, we are using the reinforcement. But why we are not using reinforcement in the bottom layer? Since we see from the picture that the cracks will be developed in full depth of the concrete slab. So is it not necessary to protect the crack in the bottom side?
No, the reinforcement's holding the crack together. You mean the,
Why not
you mean the sub?
why not 2 layers reinforcement we are using? Why one single layer?
Top and bottom.
In our project, the good professor Dr. Samsullah, he has given us the design providing these 2 layers of reinforcement. That's why I am asking you the question. And in ASTO, there is also provision that if the slab thickness is more than 14 inches, then 2 layers reinforcement should be used. In the ASTO 1993. Right. It is suggested like that.
Okay. In our experience, just 1 layer, isn't it?
And we have used many techniques in our project to reduce this cracks, especially cracks are there, but we have able to produce the cracks more space, right? Like 5 meters, 6 meters, like that. So no close, so much cracks are not here. If you can visit our site, you can see it is not so closely. We have provided so many techniques of casting and curing and saw cutting. Many methods been used in our project.
Okay. I would say that you want cracks closely spaced, because if they are further apart, you'll get more movement at each crack. So it's good to have closely spaced cracks, about 1 meter spacing, approximately. Some will be half, some will be up to 2, but it's better to have closely spaced cracks more often. Okay, so that's now roller compacted concrete. This is relatively new, and what happens is you're laying the mix. The mix is very stiff, so that as soon as you lay the mix, you can walk on it. So you don't necessarily need formwork at the edges. It's normally paver laid. So you pave it. I think you can use an asphalt paver. It's a very stiff mix, very low water content. As I say, as soon as you've paved it, you can walk on it. Then what happens is you roll it almost immediately, and that induces very fine cracks in the material. Now, the problem with roller compacted concrete is that the surfacing is not very good. It's not suitable for traffic, because you haven't got the surface texture there that you can induce in a normal concrete pavement using tines or a brush. So the surface is not very good. So it's normally overlaid with asphalt, but it's being increasingly used, increasingly popular, and maybe it's the way forward, because you don't have joints, you don't have steel reinforcement, so there are quite a few benefits to it.
It's like this stabilized base. You can see it's kind of a stabilized base.
Yes. Yes.
Speak a bit louder because it is
Stabilized base.
sometimes it's
Oh, sorry. Okay, yes. Some good advice there. Okay, so that's roller compacted concrete. Ultra thin reinforced concrete pavement. I just put this in here because it's used in some places, but it's not for a new pavement. It's normally for a rural road that's you've got problems with the asphalt. So you take off the problematic asphalt and you put a very thin reinforced concrete layer on the top, which is utilising the strength of an existing road. So I just put that in for information. In the UK, we have used it on a few roads where, for example, there was a length of flexible composite pavement, which was asphalt over CBM, but there was lots of longitudinal cracking along the length of the road. So what they did is they planed off half the asphalt and replaced the top with a very thin reinforced concrete layer. So, as I say, that's not for new construction, it's just a rehabilitation method for non-interurban routes. This is for, again, low traffic or lower traffic, not a high traffic route. Yes, that's what I think. Precast concrete pavements. I don't know anything about precast concrete pavements, so I'm not going to talk about them. I don't know. These are becoming increasingly popular in the United States, but we don't have them in the UK, and I haven't worked with them. So they're available, but I can't talk about them because I don't have any experience. Okay. So here are the types of pavement that are mentioned in Road Note 31. Some of them, the designs aren't given, they're just talked about. And as I say, precast concrete pavements are not included. So there we go. I've given you an introduction to concrete. I've talked about the different types of concrete joints. And I've talked about the main types of concrete pavements. So thank you. That concludes my first talk. Any questions? So what about your experience of concrete roads? I understand there's new construction going ahead. New CRCP roads being built in the north. Does anyone have any experience of concrete roads or can share their experience?
Thank you very much. Good presentation. And we have actually interacted during your presentation. So the thing is, our experience of concrete pavement in Bangladesh, actually, there's quite a lot of opposition here, mainly because of the riding quality and noise. These two issues actually always, the opposition who oppose the rigid pavement, they talk about these things. But in our project, we try to make it as smooth as possible with the pavement, so that noise and also the riding quality is good and noise is less. So actually now, previously, say like 5 years back, there is a negative vibe that we don't need to use the concrete pavement. Let us go for the flexible pavement, make it better. But actually, because of the repeated failure of flexible pavement in Bangladesh, it is not climate resilient.
Yes.
Yet in Bangladesh, because we haven't used the like latest technology, like yesterday, I think we have shown about the epoxy bitumen. We haven't used it. We have just started using PNB. So because of this repeated failure, we actually had to move to rigid pavement. Now our experience is what we are seeing in our project. That's now everybody is beginning to like this, because in our project the concrete pavement is smooth and much less cracks, and so people are starting to like it because it is long lasting. So there will be less maintenance cost there. So I think we are in the transition point. So we are slowly moving towards rigid pavement, and I think we are being successful at this point. But I don't know what will happen in the future. We will have to observe our pavement. We have made this pavement very carefully, with supervision, with good design, involving the university teachers, involving our pavement experts, involving our long-time researcher of rigid pavement. So now I think people have started to like the rigid pavement. I think it is the right way to go in Bangladesh, because we have a very bad monsoon, you know that, yeah? So rains, flooding. I think this pavement, the CRCP, especially CRCP, I think we should start using more. But another problem is about the cost. The cost is actually a little bit higher cost as CRCP, you know that. So we don't want to go this natural tendency to not to build high cost roads. But actually lifetime cost, if you think about lifetime cost, it much less also. So the thing is, I want to say that this is actually where we are moving. I think it is in a good way, but it will take some time to engineers to accept fully about this CRCP. I think the future is the future of Bangladesh highway is actually CRCP.
Yes, CRCP.
Let me add something with my respected PD, sir. He has covered everything almost. Some other benefits of concrete pavements are also there. If it is not even laid by the paver, we have seen that the major highway like Dhaka-Chittagong highway, Dhaka-Mymensingh highway, the Sylhet-Pulagons highway, the heavily traffic load, heavy duty roads are built of concrete pavement, the main sections, and it has given the best service so far. Dhaka-Chittagong, if we tell about the Dhaka-Chittagong highway where I worked, 31 Bajar sections we covered with the concrete pavement, with the marketplaces. Covered all the marketplaces covered with concrete pavement, and it is giving still now giving good services. Though the riding quality is not so good like our project, like our Sussex 2 project, since it was not built by the pavers. But if we tell about the sustainability, it is well sustained. We can put it, no maintenance cost even involved there. The last patching was done in 2016. So if we tell that the oldest one is more than 8 years, and the last one is more than 6 years. And if we say about the Dhaka-Sylhet, not the Dhaka-Sylhet, it is the Sylhet-Pulagons road, 30-kilometer long road. Almost 95% traffic are the truck traffic carrying the boulders and the stones. So heavily loaded trucks are there. In the last year, 2022, the record break flood happened in that area, and most of the roads are damaged except that one. So it is climatic resilience. If we tell about that, it is resilient, climatic resilient pavement. Though it is not constructed by paper, it is manually laid, and writing is not so good. But another important thing, that is the foreign currency savings. We know that in Bangladesh, the foreign currency reserve is a very important issue for our economy. In the bituminous pavement, the thickness of the pavement, total pavement structural thickness is almost double than compared to the concrete pavement. So we need to import the boulders, the stones from the neighboring countries like India, Bhutan, Nepal, or other countries like Vietnam even, expending a lot of foreign currencies. And since the thickness is too high, so it has to be compacted layer by layer using the rollers, which is operated by fuels. I have a calculation that if we construct 1 cubic meter of flexible pavement, it requires around 30 liters of fuel. Whereas there is no use or almost no use of rollers in the concrete pavement. So no use of fuel almost, and only 5 liters of fuel is required to transport the material and operate the plant. So this is the scenario. Every cubic meter concrete construction saves 25 liters of fuel, which is the fully imported raw material in Bangladesh. And I have a calculation that if a 6-lane road we build with concrete instead of flexibles, it saves almost $1 million. So it's a big issue for our foreign currency reserve. So this is the scenario. I intended to add this one.
Just
So
let
thank
me
you very much.
let me just add.
Chat is not working. This is a question that you have received.
So the issue is here actually, which one is more sustainable? Yesterday I asked a question actually, because you have shown that the concrete pavement is less sustainable than the flexible pavement. So which one is more sustainable? But if you compare,
Sustainable.
sustainable means environmentally acceptable, more acceptable.
Okay.
So which one is more acceptable? So you can think that cement is one of the largest polluters. Yeah, cement can be, so easily you can say that concrete pavement is less sustainable. But think about this. Think about the use of the basic material stone. You are using much less stone amount in this rigid pavement, much less one stone than the flexible pavement. Also, you are using more fuel, more equipment, more fuel during construction of flexible pavement. So if you compare all these things, I think that the concrete pavement will be more sustainable than the flexible pavement. I asked the question yesterday. I think I haven't got the answer, but I have seen a graph that shows that the rigid pavement is less sustainable. But if you compare all these things, I think the rigid pavement will be more sustainable. Thank you.
Yes. Okay. Concrete pavements are generally more expensive than asphalt pavements, but they are more durable and more long-lasting. So the location is crucial. For example, I've just come from Kenya, where they built a new expressway through the middle of Nairobi. Now, all the heavily laden trucks are going to Uganda. They're going one way, and some sections of the expressway, it's a steep hill going uphill. So what they've done is they have built that section in concrete, because you have HGVs going up a hill at 5 miles an hour, very slowly, very heavily laden. And if that was an asphalt road, it wouldn't cope. So they've built that section in concrete, which is great. So the uphill section, lots of stress on the road, they've built that in concrete. But the downhill section with lightly laden heavy vehicles is flexible, it's asphalt. So concrete is a great material, but it can be more expensive, so you can target when to use it. For example, in hilly environments where you've got a hill going uphill or steep, tight curves and water running onto the road, asphalt may not survive in those locations, so concrete is great in that situation. You're saying you're building CRCP roads. That's fantastic. They are the best type of concrete roads. Very little maintenance once you've built them. They're very strong. They're perfect for inter-urban expressways or heavily used roads. They are fantastic. For the jointed concrete pavements, most of the problems are to do with the joints. So I will show you some pictures of problems that can occur. So if you can afford it, go for the CRCP road. That's brilliant. And another benefit of CRCP is we have areas of the UK where there are mine workings and the road subsides and all sorts. It can be quite uneven. So a CRCP road will bridge over weaker areas, and it's fantastic. You see some roads where the road under the subgrade underneath is sort of collapsed and moved away, but the road is still there. It's like one long bridge over any weak areas. So CRCP is fantastic, but it's very expensive.
Actually, about the expense in Bangladesh, actually, the bitumen is very expensive also. But we have a lot of cement factories in Bangladesh, so cement is easily available, but bitumen is not easily available. So if you think about that, actually, the cost comparison, that is not that high in Bangladesh.
Yeah.
In situation of Bangladesh, the complete is not that. Cost is not that high.
I was reading online that 90% of the cement that you produce in this country is exported.
Well, about the numbers, but a lot of cement we export, so we have easily available cements.
Yes.
But we don't have bitumen. And we are not getting bitumen, so like in my room, we try to procure bitumen, we cannot get bitumen. So it's a problem for us. So it's better to move towards CRCP, easily available material. Now the technology is established. So I think it is our future. Thank you.
Yes. In my next slide, I'll be talking about pros and cons of different types of concrete pavement. And CRCP will have lots of pros.
I have a small study in 2015. I made a comparison of cost between rigid pavement and flexible pavement. If you give me 1 minute or 2 minutes time, so I can present my study in 4 or 3 slides. So
Yes.
stay with nice.
This one out. It's USB.
Yes,
It's done. Oh, thank you. We had a question from viewers.
This
Who was saying for CRCP, is there a minimum or maximum length of road you should construct?
Let me share with everybody online.
I would say no. There's no maximum length for CRCP. For a short length, it would depend on your economics. There are some short lengths of CRCP areas and so forth.
Good morning. Ladies and gentlemen, thank you. Good morning, ladies and gentlemen. I want to show one study which I have made in 2015 in Siraj Salodigar Kupaniganj Road, and I get all these flexible pavement design and rigid pavement design from the Mahbub, and he gave me to me. I just with the RSD rate schedule, I just compared this thing, and I find that what I find, I'm going to show it in a short way.
The next one.
Oh, no problem. Close it.
Yes. Just press the right button. Could you introduce yourself again?
Oh, I am Mr. Nuruzzaman, retired additional chief engineer, Roads and Highways. I am Mr. Nuruzzaman. I am a retired additional chief engineer, Roads and Highways. Now I am working in a consulting firm. Actually, I am a bridge design engineer. I have a great passionate on pavement design, and I have done so many 3 or 4 papers on it. And when I was in field in ASD, I find that why these things that happen and why the cost of. There's another study I have made. Why the cost of road construction in Bangladesh is higher than the India. That's the thing. Do I show this thing? Okay. Go ahead. Yeah, next one. You know these.
Maybe we can skip to the first part and then directly go to the presentation. And I would also request the participant to write down their question and answers. Maybe at the end of the session, today's session, we'll get back to this presentation and then ask the question.
Just 4 things. The thing I want to discuss about the comparison of flexible and rigid pavement. If you see the flexible pavement, total length depth of the pavement is almost 800 millimeter, and for rigid pavement it is 550. It matches with the Dr. Oli's explanation. And second thing is that about the cost. If you see the cost, flexible pavement, it cost total cost 8 crore per 2-lane highway, but for flexible pavement you need maintenance and other things, so it cost ultimately totally 11 crore. But rigid pavement, it lifetime is 20 and it cost 9 crore, something like this. So if you this is my thing that I want to show that for the rigid pavement, we can use in the rigid pavement we can save stone, which is not available in Bangladesh. So we can reduce our importing of stone. And second thing is that it is initial cost may be high from my study, but the long-term cost in rigid pavement is cheaper than the flexible one. Thank you very much.
Okay. What is the difference at the initial stage?
Oh, yeah, you can see.
You have completed the life cycle costing, but we are saying that what is the difference at the initial stage?
Yes. Huh? For the gate. Yes.
The second one. Ah.
No, sir,
And
yeah.
payment, yes, payment initial cost for the basic, for the 5 Pro, more than 5 Pro, 5 to 6 Pro, and for the rigid payment, it cost is close to 9 Pro. Yeah, all the datas are very old. It was the original rate schedule of 2015.
Under the same traffic condition.
Same traffic condition, same road. It is Sylhet Salotiko Company Road. They designed one part of it for a other area for the rigid pavement and the other area flexible pavement. I took these two things from the bridge design unit, road design unit, and compared this thing. And I made a study and I published it in our journal. There is detail on it. Thank you.
But you mentioned that there is a big difference in costing between India and Bangladesh.
Hey, there is another paper. I will show you the next.
Yeah, please. We are also.
And because I find the PWD in West Bengal rate and Bangladesh rate, and I find it why cost is different. Thank you.
Thank you very much for your contribution, John sir. We'll get back to the original presentation which we are now.
Close the
So,
So regarding the cost, may I add something? So it is the study of Munna sir.
Yes, sir.
May I add something with the cost, regarding the cost? Previously it was a little bit higher, but it is the design of 2015.
Yes, in
Nowadays we are
and
nowadays we are designing our flexible pavement with the PMB, you know, and the PMB's cost is too much high. And if you compare nowadays, if you compare, say, the running project of Dhaka Sylhet Highway, if you get the design of both the concrete pavement in the further sections and the design of the concrete pavement, the other rural sections, the flexible pavement, you must see that now the cost of concrete pavement less with compared to the the flexible pavement. Concrete pavement cheaper.
still
In the initial cost, even in the initial cost, it is cheaper if we compare with the provision of the asphalt with PM. Thank you. I have done it. The comparison is with me.
Thank you.
Okay, thank you.
Finish.
Okay, well, we're trying to get back to the next presentation. Can I repeat the answer to that question that was online about is there a sort of maximum or minimum length of the RCP? In my opinion, no. You can build a short length of the RCP, but it would be very expensive. And a long length is fine. Obviously, you will have bridges along that length, so you would need to have a break in the CRCP. And you will need expansion joints at the bridge to protect the bridge, and you will need ground anchors at the end of each CRCP section. But now the length of it, you can do as much as you want with it.
I have another question. What is the maximum lane width or panel width of CRCP and also CRCP? Limit of the width. Panel width.
Limit of the width, it depends. It depends if you're laying all lanes in one at one time, or whether you're laying each lane separately. Some paving trains can lay three lanes at a time, I think.
No, wait, I want to know what is the limit of width. Can we provide a pavement in GRCP 5.5 meter or 6 meter width like this, or a width like one length 3.7 meter width like this. What is the maximum width of the panel?
You mean for each lane or the number of lanes for the carriageway?
Each lane.
Each lane, you would normally, I mean, in the UK, it's 3.75 meters lane width. If you lay a wider concrete slab, it will crack down a little. So, you know, you want, the ideal shape of a concrete slab is square. That's the best shape. When you go to airports, you'll see they are square concrete. But when you're laying a road, for efficiencies, it's normally a lane width by 5 meters, because that is the sort of natural crack spacing that the concrete will occur.
So in your GSCP, you show the width length of the sector is 25 meter.
The JLCP,
GSCP 25 meter.
yes.
If then what will be the width? Each lane will be 3.7 meter or more. If you want to construct it is 6 meter, then it should be okay.
6 meters is too wide.
So I want to know the limit. What is the maximum limit of width of each lane? Is there any reference in your guideline? And also CSCP also. There is the limit of the width.
It's normal that you try and get your joints that they're not trafficked. You don't want the traffic running along your joints, because that can cause issues. So the normal thing is to lay concrete in lane widths with the joint between the lanes, so that you're not getting traffic running on that joint. So the normal thing is to have lane widths like that. You can build a 4 meter, 5 meter wide lane, but that's just expensive. Are you saying you'd lay the concrete in 5 meters and then have one lane width, the line markings at 3.75 meters? Then you would have the next lane, you would have traffic running on that longitudinal joint, which is not a good idea.
I am asking this question because we have 2-lane road. Think about that. We have 2-lane road in each direction. 2 lane 7.3 meter and 1.5 meter also some hard shoulder. That means 7.3 plus 1.5. How much? 9.8. One on each side. It's 9.8 meter. That is the width become 4.75.
9.8 meter width.
Yeah. Width provide 9.8 meter in 2 lane.
Is that for CRCP or for jointed?
You know, it's the jointed. GSCP.
Yeah. I mean, you can lay it in that width in one pass, but you would need to put longitudinal joints.
Yes, we can provide, but I want to know, is there any limit of maximum land width? In your guideline, is there any reference? What should be the maximum land width in GRCP or also CRCP?
Just one thing, actually, widths depend on the paver, size of the paver. How much wider the paver is, yeah. In our case, we can make 9 meter width. Yes.
Yes, sir, I know that it is,
But you can construction technical,
but what is the design standard? I will consider how much should be the width, because I don't get any reference about the width.
width. Did you get the question actually, but the is
Not really.
the wide of the one stretch, how much wider you can make pavement in one go, much wider.
Normally it should be lane by lane. That is what you are telling. But he is asking if there is any limit. Is the lane width or it can be extended to more?
Well, it's the paver size.
No, we don't paper, let about paper, we will not use any paper.
Better, in that case, better to use lesser size
that will reduce the chances of crack. But in some cases, there are some pavement we are designing for only 5.5 meter width. In as a single lane.
Yes, yes. Normally that's what we are saying.
Now, one thing I haven't talked about is that when you're laying out a concrete road, you don't want trucks, HGVs running at the edge of the concrete, because that's where the concrete is weakest. So what you want is at least a ½ meter shoulder, possibly more, so that the truck is not running at the edge of the concrete, it's running away from the edge. So in the most pavement designs, you have designs for thickness of concrete without shoulder and with shoulder. We would always recommend having a concrete shoulder, whether it is an integral part of that slab width, or whether it is laid as a separate narrow lane, but tied to the hard shot, tied to the main lane. So the trucks don't run near the edge of the slab, because that's where it's weakest. So you need that sort of gap where the trucks don't run.
Challenge we are facing in our pavement regarding the road marking. Normally, the thermoplastic road marking doesn't sustain over the concrete. Is there any solution?
We don't have a problem with road markings sticking to concrete.
But we are facing. You may not face this in your country because your country is a developed country and law-abiding tendency is too high. Because the vehicles do not break the lane discipline. They do not do not change the lane, one lane to another lane. And when the trucks tire pass over the road markings, it doesn't sustain. It is not so sticky as it is compared to the flexible pavement. The bitumen and the thermoplastic paint, there is a good bonding. But in the rigid pavement, the bonding is not too much. Is there any solution?
I'm sorry, I'm not a paint expert. I don't know. There is, in the UK, there can be an issue because concrete is so light in colour that if you have white lines, people sometimes say they cannot see them if there's glare. So in some cases, we put a thin asphalt spray and then put the white line on top, and then the white line is more visible. So that could be one solution there. How do I get to the second presentation? Sorry?